Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's with my extreme pleasure, and not without some political risk, I would like to introduce another fantastic software company in the East Side. These folks are in Bellevue, recently moved from Kirkland, and they're famous for their game, which has really pushed the envelope of computer gaming repeatedly, first with Half-Life and then with Half-Life 2. Some academics in this audience have helped contribute technology. You'll hear about that. You'll also hear about a really exciting academic offering, and I think you'll find this to be a truly exciting session. So first, let me turn it over to Mike Dussault from Valve. And can we give these guys a big hand? This is a risk for them as well.
Hi, I'm Mike Dussault. This is Ken Birdwell, Bayrate, and Chris Green. We're all from Valve. So, we're here to basically talk about academic licensing and our engine. We're basically going to go over some of the technical features of our engine, things that we think you guys would find interesting. Originally Valve was approached by a bunch of art institutes who wanted to use our engine in their classes, and basically for their CS students, things like that to, they thought it would be more interesting for them to be building things inside of games instead of building bank databases, other typical, CS type stuff. And I want to say sort of up front, we're going to be talking about our engine, but a lot of what we're saying applies to any engine. There's a million engines out there, Unreal, Doom 3, Netaverse. There's a lot of really popular engines, so all of what we're saying sort of applies to all of that. So just at a high level, we're going to sort of run through the academic licensing program and then sort of open it up to discussion about some of our technical features. So currently we have 30 students in the academic licensing program at Valve.
Schools.
Oh yeah, more than 30 students, 30 schools, and 1,260 seats currently. And just a really brief overview of what Valve is, in case you don't know. Valve was started in 1996 by some ex-Microsoft guys, and they made a game called Half-Life in 1998, and it did really well, sold a lot of copies. Half-Life 2, which was a sequel to it, came out last November. And one of the big focuses of our technology during the development of Half-Life 2 was this thing that we call the mod scene. And a mod is basically something where someone takes the game that we shipped, and then they take an SDK that we shipped also with the game, and then they build anything from a new texture that goes inside of the game to a completely different game. Like we ship a whole bunch of source code, so they're able to modify it and turn it into a soccer game if they want. They can turn it into marbles, pretty much anything they want. So the mod scene is this really big scene that's out there with, actually a lot of computer science students are making mods nowadays. The mod scene has, we've really been focusing a lot, and as we were developing the technology for Half-Life 2, we were thinking about that and trying to get students interested in making mods. So here's just a couple screenshots of Half-Life 2. This actually is a multiplayer version of Half-Life 2, so it's not from the original game. This is the scene inside of Half-Life 2. This is just a screenshot of Carnegie Mellon's, one of their websites, just showing how this particular page shows about maybe 20 different projects that different computer science students are working on. A lot of them are reusing engines from other games. So basically with our academic licensing program that we started, we wanted to get our engine into the hands of schools for, make it very easy for them to get it. And what they get with it is they get access to our games. The most important part of just having access to our games is they have access to our content. When they use this academic license, they get access to our a whole bunch of source code in the SDK and all the content that's available in our games. It's a lot. It's a lot nicer to be making a nice-looking demo with nice-looking content that was in a game than it is to sort of model your own, six-sided cube that's trying to do something interesting. Ken Perlin actually mentioned that he was using it at some point. So I don't know if you want to mention that, say anything about it.
Yes, and it's actually great when we're doing. I have this one student doing a project where he wanted to interactively, create for some path planning stuff. He wanted to interactively, put a couch and a chair and this and that, and he basically just took assets from the game, and it was great because he could just focus on the thing he wanted to do. So that was a big win, and it all looked good.
All right. So, so basically access to art and sound assets. Some of the things that we ship in our SDK that we think might be interesting to CS students are we ship a whole bunch of our HLSL shaders, which is basically DirectX shading language. It looks a lot like C, and you're writing pixel shaders and vertex shaders. You guys probably already know this. So there's data structure libraries. We have data structures for like RB trees, priority queues, linked lists, all types of stuff like that they can look at. We have a pretty extensive template system that we used in our networking code, basically where you can pretty easily hook up, you can basically hook up inside of your classes. You can detect changes to them automatically. You're writing code that's basically accessing all the variables in the classes, but we can automatically detect changes for them. And that's sort of for networking. That's so we can detect really quickly, have the server detect what changes it needs to send to the clients. And I'm just mentioning that because that's this really tricky data structure thing that we had to get working, so they might find that interesting. All of our AI code is in there, is included in the SDK. All of the code that we have to do radiosity, visibility calculations. There's a few other tools in our tool chain. Basically, the code to all that is included. The animation system, bone setup, all that type of stuff, acting system, IK, which actually Ken Perlin wrote, our IK. So drivable vehicles, there's code for that, image loaders, blah, 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 all that stuff. So they might find all the source code interesting. Another thing that's kind of cool with the SDK is you get access to this tool that Softimage made, and it's basically a version, it's kind of like a lightweight version of XSI, and it's fully functional, but it's got some polygon export limits, but it's something that students can use for free, so they can just go download it and export stuff into our engine with that. And we also, we're working with Microsoft. Microsoft's making sort of a lightweight version of Visual C that's going to be really cheap, and they're targeting students. They want them to be able to, grab this version of Visual C. It's got some integration with our SDK. And actually, I'm going to have Kang Soo talk about that.
Mike, can I ask you a question first?
Yeah.
So when you say you're making your AI system available for folks, are you saying that people could modify that, then introduce it back into Half-Life so they could see different behaviors of the characters?
Yeah, like the first thing you do when you get the SDK is you just compile the Half-Life 2 source code. And then usually what people will do is they'll make small changes to it. They'll change rocket travel speeds, or they'll change the render in some way, things like that. And so, yeah, so they would just compile it back into Half-Life 2. Or if they wanted to start from scratch, they could reuse the concepts, pathfinding and things like that we've got inside of our AI system.
So folks at TJI now, does that sound really compelling? It seems to me like it's a dream come true. You could take a state-of-the-art engine, add AI, your own AI into it, and see if you improve it or degrade it. Does that sound good? Yeah, it seems fantastic. It's almost too good to believe. Okay, thank you.
All right, thanks, Mike. Yeah, so I'm going to just very super briefly talk a little bit about C++ and the work that we've done with Valve. So first of all, I'm just going to open very quickly and kind of point out in Visual Studio 2005, which is the upcoming version due out November 7th, what the SKU plan looks like. And on the right-hand side, the different roles. And so what we've done with this release of Visual C++ is we tried to find out, what are the core roles that people have and make sure that we target Visual Studio and Visual C++ to hit these various roles. And the first thing, and you may not be able to read that very well, is in this purple box is the Express SKU. This is a whole new edition of Visual C++. We've done a couple of betas with it. And this is our lowest end SKU, really targeted at, as you can see, one of the things there are modders. That Mike was talking about, enthusiasts, novices, all the way up through students as well. And the idea with this SKU, first of all, it's a very, very low-cost SKU. And the other thing that's nice about it is that it's a simplified SKU. So a lot of the menu items and pull-downs and wizards and things that are often more confusing for people who are getting started have been removed out of these SKUs. So for a person getting started with Visual Studio development, this is often is the ideal place to start. And as you develop more expertise or start doing different types of things, you'll move up through the standard professional and up through the top, which is the latest version of Visual Studio, which is Team System, which adds support for people doing enterprise level development with a profiler and static analysis tools, a special SKU for testing to do code coverage testing and unit testing, as well as an architect SKU as well. But what's really interesting again is, the integration and work that we've done with Half-Life 2 and Valve. So, as Mike was talking about before, the Half-Life 2 SDK is this great SDK for doing game development, and the tools that they use in-house obviously are also Visual C++. So we thought, let's make sure this integration experience is as good as possible. So in this latest release, and we're actually going to be officially announcing this, I say planned release, although I guess it should be planned announcement, worldwide is going to be late August at the Australia Tech Ed. And that's when we're going to actually be showing it for the first time. But I can talk to it right now. And actually, I think this is the first time we've told anybody outside of the product units and outside of Valve about this plan. It's really quite cool stuff, though. So the idea here is that we're actually going to have a Half-Life 2 add-in into Visual C++. So you end up getting this first-class experience now if you're doing SDK development. So what this will allow you to do is when you go and you create a new project, and if you've done this in Visual C++ in the past, you've seen, you go, you do the pull-down menu, you say new project, you pick Win32 console project, but now what you can do is you can say, I want to create a new Half-Life 2 project, and you can say things like, I want to now create a new weapon, and we'll generate the code spit, and we'll have the wizards, and then we'll have the Steam integration, which is the bullet point down there, which will automatically go ahead, download the latest bits from the SDK on your machine. So you have, again, this great integrated experience. You also get, things like built-in task lists. So again, if you're a beginner getting started with the SDK, one of the toughest things is figuring out, how do I get started? What do I do? So we're going to have this built again into the IDE where you could just simply go and click the task. It'll take you to the point in the code and give you an idea of the types of things that you can start coding to make, effective changes and really get your foot in the door, doing the mods. And another nice thing we'll have is we'll have Half-Life 2 news feeds getting piped directly into the IDE. So again, these are the level of integration and the types of things that we want to start enabling. And we think, with students out there, this is the type of thing that's very exciting, gets them in the door quickly, a great tool set. And as, we start getting more and more experience with this type of thing, we could add even better user experience. So anyways, that's all I was going to say. And I'll go sit back down and wait for some questions later. Or you can ask now as well. Oh, we have a question right here in the back.
Can you show a demo of using this integrated system?
Yeah, so unfortunately, no. So this is the thing that's actually not going to be shown until late August. I wish I could. In fact, I asked to get screenshots, and I couldn't get those either. Yeah, I know you're probably thinking, that would have been the thing to have.
We'll have videos on the Coding for Fun website. That's msdn.microsoft.com/coding4fun. So you have to check out that website. Lots of really cool fun projects on there. So no plug there. But would not watch it on the landing page for where we actually go the plugin for Valve SDK in C++. So we'll have some videos, lots of fun examples.
Brian, do you have a date on that?
That'll be probably in conjunction with the August second announcement, if not the week after.
Okay, perfect.
So I'm a bit mercenary. I think what you guys are doing is exciting, but I'm coming from visualization from life sciences, and I'm curious, would we have opportunities to maybe not have couches and guns, but maybe normal kinds of shapes that I could look through genes and connections and still maybe have a little mist because you want some environment stuff, but I can bring in some of my own shapes and connections?
The Valve Half-Life SDK and basically the mod community is generating thousands of models by the fan community. So if you can make a file in any of the free or off-the-shelf 3D applications, converting it into a file that can be displayed in the game is pretty trivial. Think about a kid who wants to make his own special gun. The difference between a gun and a gene is just the number of polygons and the intention.
What about documentation and tutorials and things like that?
Wow. Hello? Yeah, we just started a wiki recently.
That was going to be my next question.
Yeah. So I hope we have it on the slide. It's developer.valvesoftware.com, and you go there, and it's actually been doing pretty well. It's about 100 edits per day right now, so it's growing. People are adding lots of articles.
That's fantastic. Thanks for doing this.
We're just going to finish the slides and then open it up. Oh, one more? Yeah.
I was just curious, what is the learning curve for this? If I'm trying to teach a particular subject, whether it's AI or even like an intro programming course or something like that, how much of my time am I going to spend nursing them through getting started with it as opposed to actually teaching the content I'm interested in?
It really depends on like what you're doing with it, but if they know how to compile stuff and run it, then you can basically do that pretty easily. Like if you wanted to say create some models in the game and have them moving around, that's really easy. There's just commands to create the entities, and you specify which piece of content, which model you want associated with it, and you move it around. Yeah, it really just depends on which systems you're getting into. If you want to get into the render and you want to start changing all of our shaders, then you have to know a little bit more. Percentage-wise, like 70%. I don't know. The source code, 80. Yeah. The parts that aren't included are, for example, like our BSP data structures. Some of our hidden surface determination, things like that. Binary spatial partition. So it's just a few of our internal data structures, like our audio mixers. Those aren't exposed right now. But we actively update the SDK, so we just haven't heard requests for people to have things like the audio mixers, but if they wanted it, we'll put an interface on it. But you do get access to, specifically for rendering, the interesting thing is that you control the whole rendering loop. So basically the order that everything's drawn in. Water is, the way that we draw our water has a bunch of steps, and it's kind of complicated. You're rendering things into render targets and then doing all that stuff. So, but you do have access to like that kind of thing.
Is there any possibility of getting a managed version? Managed C++ or?
So what I can say that, so actually when we first started talking with Valve, that was actually one of the early things that we discussed was exposing maybe at least a managed object model. And that's something that we're still very interested in doing. Although we decided for this first release, we wanted to go ahead and try to get what we thought was the low-hanging fruit and the thing that we thought would have the most value to the customers immediately. Although we certainly think, going forward, a managed object model would be interesting. There's a lot of interesting issues to figure out when you go to a managed object model, especially with the game like Half-Life 2.
Can you just flip the switch like they did in Unreal?
Can you just flip the
CLR switch like they did in Unreal in a couple
Oh, you mean with Quake 2?
Yeah, Quake 2.
Well, so Quake 2 didn't actually. So what he's referring to is throwing a /CLR switch, which generates managed code, and they did this with Quake 2. So what we'd like to do is we'd actually like to really expose a real managed object model with garbage collected types. Whereas if you throw the /CLR switch, the types aren't garbage collected. So you're kind of halfway there, right? So you end up having CLR entry points, but you don't have a real managed object model. So going down that path is one thing, although it's probably less interesting than actually just wrapping GC types around it.
This slide just shows a couple examples of things that people have done in academia to use using an engine. New Ties was something that they just released a press release about. We don't know a whole lot about it, but they made this thing. They actually used the old version of our engine, and they produced this networked virtual environment, and they said they were trying to develop societies and culture inside of it. That's all we know. Mimesis was a guy that contacted us actually pretty recently, and he's been working for 4 years with game engines, and he started to get interested in ours, so he's moving his stuff over to ours. Okay, there he is. Hey. So do you want to say anything about that?
Sure. So I've done a lot of work both on the research side and on the teaching side using Unreal Tournament and its various iterations. And especially for the research side, ended up kind of butting up against the boundary of Unreal Script and how deep into the engine internals I could get. But with Half-Life 2, there's so much more that's exposed that, you know, it's just it's an incredible difference. And I had a bunch of students who were very familiar with C# and C++ and Unreal Script, and it took us about 2 or 3 weeks to learn the whole environment and port over all of our software from running with UT into Half-Life 2. So the development time was pretty minimal.
So, oh, another one? Yeah.
Can you tell us more about the AI that you're using and how that might be used for teaching an AI class?
Actually, we release all of our AI code, 100% of it. You have full access to it. It's a fairly simple schedule-driven system. Entities in our world go into states, have certain senses. Those sentences feed into an input stream, which then selects different schedules to run. These schedules are simple things like, you need to go over here, you need to pick up this object, you need to do these certain sorts of things. Each one of those atomic actions then has a bit of code associated with it, which then either drives the animation or it drives some state change in the world. It's very open. I'm not really sure what more to say, other than you have 100% of it. It's, go.
So when I invited these guys to speak, I emphasized that they not sell anything they're doing. So if you guys need to sell something, please feel like the restraints are off, because they're really being modest here. Their AI stuff is completely state-of-the-art. Their graphics stuff, completely state-of-the-art. The game is a huge market success. They had all sorts of slides that would tell you this. We asked them to take them out because we didn't want to offend your sensibilities. But really, they have a phenomenal amount of technology here, and I'd encourage them to really talk about it because it's really just best in class.
And if you act now, we'll throw in.
It's a fully hierarchical system. It's all C++ class-oriented. You have class behaviors which you can write, which change fundamental core ways of how the entities detect the world, scan the world, interact with their different inputs, interact with their own memory systems, communicate to the other NPCs around them, different state information. It's pretty, I could go on for an hour, all the things. Though what's also nice is you can get in there, you can jump in, you can make a simple AI in about a day. If you want to make a very complicated AI, it'll take longer, but you can make changes to an AI immediately. You can make a new simple AI in about a day or two at most, with a new character who has new kinds of behaviors. And then you can just start layering on that. It's all hierarchical, so if you write base class behaviors, everybody inherits the abilities to do what the base class has, and then each one can go up in a higher chain of hierarchy. The very top of our system, we have the characters who are fully actors. They understand how to control their bodies. They understand how to look at people, maintain eye contact, when they should blink. All these other things, that's in the very high level. And then as down below, we have a concept of, I understand I'm in a group of people. I understand of people I talk to, things I can communicate with them. And then on down, I understand how to interact with the physics. I understand the world. And it works all the way down to the, I'm a simple box who knows how to animate. And then actually, I'm a box who doesn't know how to animate. But it's a fully hierarchical system, and you have access to every single point along that chain, if that helps. Sorry.
So, so I'm interested in using possibly something like this to teach concepts in systems, not necessarily AI, not necessarily graphics, but things like real-time scheduling, things like concurrency. how easy is it to find sort of the best place to tell students, okay, now go try a different scheduler instead of, doing the rendering in this order, do it in that order, and it's going to be better, and try different schedulers, things of this sort. Is that something that's easy to find, or am I going to, how?
You look on the wiki, it'll probably take you half an hour or so to find it, then maybe a couple hours to figure out how it all works, and then start banging on it. Most of these things are pretty easy to find. There is a lot of code. If you really want to understand the entirety of the system, there's probably 500,700,000 lines of code. You don't need to know that in order to get started. You can get started if you pick a subsystem with maybe a few hundred to a few thousand lines of code and start making simple changes. If you want to make a major architectural change, it'll be a couple weeks worth of work, but it's not impossible.
Okay, thank you.
Okay. I just want to clarify, because it's unclear to me what you get with the academic license versus what you get with the original game. Because, of course, you buy the original game, you get to mod.
Well, original game, you buy at a store, cost you anywhere from $40 to $60, depending on where you buy it.
The academic license is definitely cheaper.
Academic license is $10. You can renew it for as long as you want. It's $10 one-time charge per seat. Basically, what we do is we turn you into an internet cafe, which means you, as the instructor, controls all of the keys, all the key access. You dole them out to your students. You can revoke them when you need to do it for your next semester. It's basically you're a full internet cafe, but you don't have to pay us money like an internet cafe, and it's kind of a nominal charge just to make sure you're serious. But
okay, so basically the charge is for the internet. Well, basically the difference is the control you get over the licenses and that sort of thing, as opposed to the actual game.
Correct.
Okay, I just wanted to make sure that that was the case, because it was unclear to me.
You actually get turned into a mini internet cafe, which means there's one central machine that controls all of the other keys. There's other management and maintenance functions which make it simpler by being a virtual internet cafe, but it's just an academic version of that. No. Steam is an automated file downloading system, downloads in the background, fills out your data cache. Basically what you do is you type in you want to play our game. Our system goes through and determines what assets you have, which ones you don't have, and then starts populating your machines with all of the resources it needs. And it does this all automatically. We feed it out over this multi-gigabit pipe.
Well,
correct. We then send that copy just to the administrator, and the administrator then doles it back out. So
but they can get it from home. That's one thing to note, is that the students can use it at the class, but during the semester they get a key, and then they can take that home and download all the same stuff and work from home on everything.
I know you guys have a wiki and a support plan in place for licensees, but I'm wondering if you guys would be interested in supporting a university-hosted web community specifically for your academic licensees.
Sure, why not? Yeah, it's all of our stuff online is thankfully done by our fans. About 80% of it is all fan generated. We'll go through and correct minor mistakes and answer difficult questions, but it's wonderful. I looked on there one day and there was all these tutorials, and I said, wow, this is great. Wonder when we did this. And the answer was, we didn't. A bunch of our fans did, and all we had to do was go through, find a couple of little things that we go, oh, there's a better way to do this, fix them up, and then 1,000 people can see it.
One of the things I've noticed is that there's a big difference between the typical modder who writes a mod and then maybe writes a tutorial about it and posts it on a mod site, and a professor who wants to teach a class using a game engine. And tracking down mods can be a challenge for somebody who's never done it before, and not all the tutorials that are out there are that well written and pedagogically kind of effective. And so it might be that if there was something set up for academic licensees and kind of had them sort of centrally involved in the management of it, it would kind of ease that path in for us.
Absolutely. You should just end up contacting Doug Lombardi. He'll set you all up. Absolutely. We didn't bring any PR people at request of Microsoft, so the person who could answer your question isn't here, but I don't see any problems with it. Let's go on.
All right. So, yeah, lots of our mods come from CS students. Counter-Strike was a huge mod. It did really well, and right now it's got, you know, a ton of players out there online.
More bandwidth in Italy.
Yeah, more bandwidth in Italy is what Counter-Strike uses right now. Eclipse is a mod that came to our attention about 3 weeks ago, and we were really surprised by it. It actually confirmed this theory that we have, that a lot of the greatest stuff that comes out is stuff we don't hear about them at all until they release. There's like a lot of mods where they're sending us, you know, huge, gigantic emails all the time about every single detail, but the guys that always surprise us are the ones we never hear from them. We don't even know who they are until they come out with this thing. And Eclipse was really cool. They were doing all these post-process effects. They had they were doing blooming. They had a sort of a blur shader that was added on. They had like a magic effect where you would charge your power and the whole screen would sharpen, sharpen, and sharpen more until you released it. So Eclipse was made completely by computer science students. And so this slide, we're just going to leave it here, and we're just going to briefly talk about each of these topics as quickly as we can, because we want to just drive it by Q&A. So we'll just let you know what each of these things are, and then we'll just go back and forth with any questions you have about this stuff. So Chris Green's going to talk about HDR.
Hi there. Testing. One of the technologies we're working on right now is what we call HDR. It's some of you probably know the acronym, but it stands for High Dynamic Range. And what we do is, on a normal computer graphics display, you might have a contrast range of something like 2,000 to 1 or worse. But the real world has contrast ranges between light and dark of hundreds of thousands to 1 between, say, the sun and the ground. So with our high dynamic range rendering, we actually store a lot of the maps and textures used in the game in a floating point format that represents real world illumination levels. And we run our global illumination algorithms in that space, and with the goal of mapping that down more accurately to the computer screen to produce effects that more closely match what you see in reality. And some stuff that comes out of that is we get like really beautiful reflections on water and sand. And I think I can actually give you a demo. This is a level we've been working on called Lost Coast. It's kind of a tech demo, and it's showing off the high dynamic range rendering. And there's a couple things it does. It does a auto exposure. So if you go over to a really dark area, and it's probably so fast you couldn't see it, but it's constantly measuring the lightness of the scene and readjusting the exposure. And it's hard to do this while holding a mic. There's a bloom effect where you can see the sun, the really bright sun back there is actually leaking some overexposed pixels over its background. And you see the water has really beautiful white reflections on it. And that's something we actually didn't have before the HDR rendering, because say our water is like 25% reflective, and we're storing our reflection maps in normal pixel units. Then the brightest something could be, once it's been multiplied by the 25% and put on the screen, is 25% of the fullest bright pixel. While here, even though this water is only slightly reflective, the super bright sun ends up reflecting as a full white on the water and on the sand. See the reflection right there. And I guess also, so this is another graphics item, we do an interesting technique throughout the engine that is, I think we're the first game that did this. I don't know if there are any that do it now, where we do offline radiosity solutions for our world in order to have light maps so that we can have realistic global illumination with shadows, secondary reflections, color bleeding, all the effects you get out of a radiosity algorithm. But we wanted to have bump mapping as well, which doesn't really work that well with typical pre-computed radiosity lighting, because we'd have to store the light maps at ridiculously high frequencies, ridiculously high resolutions in order to have the bump mapping work. So we actually do a sort of, it's sort of a pseudo-spherical harmonic solution where we have light maps stored for different surface orientations. We use 3 light maps, and
Slides has it all.
then the bump map is actually used to select between those different light maps. And an interesting thing about that is that our way that we filter it is actually wrong. And we know it's wrong. we ended up doing it wrong. In the first place, we did it wrong because we were able to fit it in a DirectX, in a pixel shader version 1.1 if we made it wrong, but we couldn't fit it in there if we made it right. And the interesting thing is that the wrong solution that we use actually looks better because it exaggerates the difference between different orientations of the bump map. So we actually, after we made the wrong version for Pixel Shader 1.1, we actually went back and put the wrong version on the higher end hardware too, so that it would look better. You want to talk about VMPI, Mike?
Yeah. I got this. Yeah, so one of the things that we did during the development of Half-Life 2, we used some distributed computing tools. And if you haven't heard of Incredibuild, it's really cool, especially if you're going to be having a class compiling all of the code, because it takes a while to compile because there's so much of it. Incredibuild is, it actually distributes the compilation process so you can get, 30 times faster. We use it constantly at Valve. You just have a, worker on every machine that's around. And the company's called Zoriax, it's Xoreax. So we love Incredibuild, it was awesome. VMPI is a tool that we wrote. Originally, we had a prototype based on MPI, which stands for Message Passing Interface. It's a standard for doing grid computing. And basically, our radiosity computations take a long time, and our visibility calculations take a long time. It takes a long time to compile our shaders, because what we do is you'll have like one HLSL file, and you'll define all these static conditionals, and we'll compile a different version of it for every permutation of those conditionals. So you might have 100,000 variations of that one HLSL file. So it can take a while. So we wanted to distribute that and just run those processes across all of our machines. So we wrote this library called VMPI. That saved us tons of time, which wound up improving the final quality of the game. Another topic that we can talk about during Q&A is the networking and lag compensation. Basically the whole engine is networked. You're writing stuff. Basically, most of the time when you're, like AI, for example, exists completely on the server. All of the game logic exists on the server. All of the effects exist on the client. And so it's sort of this process of, we developed a whole bunch of technology to make that, first of all, easy to do while you're coding, to basically write like a server-side thing and then describe what data it wants to have sent down to the client so the client can produce the right effects for it. And then there's also this whole topic of lag compensation. If you don't do lag compensation, then everything that the player's doing as they're walking around, it's going to feel lagged because it's going to go talk to the server, and then the message is going to come back, half a second later or so, and it'll feel really bad. It'll make them sick and all that kind of thing. So we did a bunch of work on lag compensation, different methods for that. And either Ken or Bay is going to talk about characters.
Should we do my slides now?
To your slides.
Hi, my name is Bay Rate. I joined Valve about a year ago. My presentation is significantly less polished. I was the facial lead for Gollum on the Lord of the Rings movies, so I designed and built Gollum's facial animation system and was responsible for basically Gollum from the neck up. And I wanted to talk. Now I'm blushing. I wanted to talk a little bit about an alternate approach to creature modeling and setup. So let me give you an outline of what the current steps are for creating a character. The first thing that we do is we sculpt the surface. We actually sit down in a 3D program or with a piece of clay and we sculpt what the outside of the character looks like. After we finish that, the next thing we do is we build a skeleton inside the character. And then the third thing we do is we bind the skeleton surface and the skeleton together in sort of this arbitrary mapping between the two. We test that binding through animation by basically bending the arms around or actually seeing it in a shot or seeing it in context and then going, oh my gosh, the kneecap is sliding around to the back of the leg or the chest is trying to go off with his hand or whatever the thing is. And then we fix those problem areas. And this is sort of the de facto standard way that characters have been built for 10 years. And I'm proposing an alternative theoretical workflow here. They told me it was a bunch of academics, and they said, do you have anything you want people to research? And I went, yeah, I got some ideas. So this is my this is what I would like some work on. Basically, it's sort of to do it in reverse. If you look at the previous slide, this is sort of the outside in, and what I'm proposing is that we go from the inside out. So instead of generating the surface first, I'm saying let's generate the skeleton first, then we'll generate the skin, then we'll refine our deformation behaviors, do the testing and the binding problem areas, fix-ups, and then we'll apply our details and displacements. And I had an idea for how to do that. This is just one. I think these first two slides, sort of the inside-out approach, is an area worth exploration for people in my field who build characters. So we're going to talk about the outside-in approach, which is what we have right now. The pros are that it's got good sculptural quality and it's very intuitive. It's a very obvious way for directors to interact with it. It has a lot of cons, however. It has very poor animation quality. You bend an elbow, you spend a ridiculous amount of time just getting the elbows to look good. There's a long deformation setup. You have to spend a lot of time just getting the shoulders to work, or getting the face to work, or getting the throat to work. If you watch a movie with a CG character, watch the throat. It's never set up right, and there's never lipidismus. It's kind of a hack. It's very inflexible. There's lots of problem cases. Characters do this, and weird spikes shoot out, or something looks bad. It's generally very slow to compute. Broad iterations are very difficult. That means you do a bunch of work, and then you realize that when they're bending the hand. One of the things we did on Gollum was he couldn't make a fist. We sculpted him as a surface. We did all this work. We had him in a shot, and he had to pick something up, and he couldn't actually close his hand. And going back and doing that cycle was sort of ridiculously complex. So those broad iterations are very difficult to do. It's a very segmented workflow. There's a modeler over here. There's a skeleton rigger over here. There's an animator over here, and they rarely talk to each other. It's very broken up. So you discover design mistakes too late. So this is my idea. Basically, this is sort of like if you were to imagine this as a frame execution. I'm calling it bag modeling. The very first step would be a rule-based extrusion of cubes. So basically, just a very, very simple, ZBrush has a model like this where you basically have a very lightweight data set and you just extrude it and connect it together based on a skeleton setup. The next thing you do is you make a bicubic subdivision. The third thing you do is you create what I'm calling a bladder, which is basically an omnidirectional force at the location at the start and end point of each bone, and it projects out and affects all the particles that are the vertices on the mesh. Then you do a mesh relaxation on the weights using an edge-weighted spring equation, similar to what you use in real-time cloth simulation. So it's everything will sort of sink down, but the bladders are keeping it out. And then you add more bladders, and at the end you add your displacement on top of it. The idea here is that you're sort of, while you're rigging the character, you're also modeling it, so that once you're done modeling, you're done rigging and the character just moves. There's no reason that this couldn't be moving while you're doing it. So you could theoretically be sculpting on the moving figure, which is sort of the ideal case, because you'll end up with something that's a lot more robust. So this is just the same thing again, just with a body showing average vertex relaxation, basic bladders, and then after tuning the bladders to actually make up a shape. And then this just compares the two types. So on the top is for those of you who download the SDK and start building characters, you're going to see things sort of based on what you see on the top there, which is you start with a skeleton and then you make a mesh and you skin weight it, and then that cage gets turned into a surface, which is either rendered as a subdiv or as the cage itself, and then you put normal maps or displacement maps on it. And my proposed idea is that we get rid of the skin weight part and we include this particle simulation of the surface and use bladders as the description. And the pros would be it's a unified process. It would provide robust deformations that would just work, that would move really well. It would be linear in complexity. I could see adding things like edge tags to say these edges never get shorter than this length, so that when you're doing the spring-weighted mesh, they don't compress, or this crease on my cheek here is always going to stay at this angle, no matter how the surface behaves. You're going to see animated refinements right up front. It's going to be very quick to set up, and you're going to have a very circular workflow from design all the way through to animation, so you can make a design choice and then see how it moves and back and work the two back and forth. It's sort of, in my mind, this would be how I'd love to be working in 5 years. So I thought I would just throw it out to the room and see what happens. And the cons are, it might not work. So that's all I had.
Cool. Who's next? What's next? Characters. How do I get this to go away? Oh, okay. There's no Windows key. I'm confused.
Control Escape.
Control Escape. No. I have a real keyboard at home. So So one of the system I worked on was the acting and facial animation system for Half-Life 2. I'd really like if you get your students to work with this, because I think it's cool, but kind of up to you. Basically what we have inside of Half-Life is a fully built facial animation acting editing system. We got Alex here. I can drop her eyelids. I can close them. We have a full face controls. These all just work together. This is all based on Ken Perlin actually keyed me up on this. It's all based on the work done by Dr. Paul Ekman in the mid-'70s. Basically came up with a formal grammar of how people move their face, and then a whole system of rules as to what you can do at the same time, such that, you know, if you're puckering your lips, you can't really stretch the corners of your mouth at the same time. If you do, it kind of looks like this other thing. And so he has a whole set of rules as to what you do with your face. All I've basically done is I've built those rules into a face, so you can take all of these different controls. You can pull the corners of the mouth. You can depress them, and if you do both of them together, it takes the rules, blends them correctly, and so the character does either something in the middle or one of them will suppress the other one. Basically what you have then is a face that's highly robust. You can basically send random noise at it. The face always maintains something plausible, always makes something believable. The benefit of that is then it's really easy to animate. You can take fairly junior animators or just your students. They can sit there, give them facial expressions, have them talk, do all that stuff with very little work. Lip sync is done over top of that. Let me find the, here we go. Basically, we use Microsoft's free phoneme extractor, which takes WAV files and turns them into phoneme streams. I bet you guys didn't know this. And then what we do is we play this phoneme stream carefully filtered over the mouth, so that as audio is played, that the characters.
Oh, everything all right.
Here, let me just turn off everything else.
Everything all right, Dr. Cole.
Let me just hit play. Go through the scene. My machine's set up quite right. Oh well. Here we go. Play. I put my mark to the wrong spot. Hang on. Oh well.
Everything all right, Dr. Kleiner?
Okay, here we go. I'm just going to go into a funny pucker. Basically, what this does is it generates a mouth movement string which runs independently of the facial acting system. The nice benefit of that is we then, when we went to Italian and Russian and Chinese and Spanish, we actually had all the characters correctly lip synced for their native languages while doing all of the same performances. We also have on top of this a full acting system, compositing system, movement system, so you can tell the characters or the actors to move to marks, and while they're moving, oh, you need to look at this person who's walking over there, maintain eye contact, but then turn your head towards this mark, and then, oh, when you're ready, go into a hand on your hips posture. There's a full IK system, so if they scratch their head while moving at the same time, it automatically moves their hand. Basically, all your characters in the game, all the humans, there's about 30 different humans. They're all set up the same way. So if you're building a virtual environment and you need a set of characters, it all just comes, it's all just free, it's easy to use. You should be able to get a nice simulated environment with a minimal amount of work. Plus, all of the tools come with a system. And then there's all the sorts of, you can make your own phonemes in case they're speaking Klingon or something. It doesn't really matter. It's all pretty much automatic. There you go. Yeah, that's about it for the characters. They're all fully integrated into the AI, and so as you change the lower level AI to the characters, they'll just automatically have a pretty good idea as to what they're supposed to do with their bodies, when they're supposed to go into their postures, how they play their gestures, how they cross-fade back and forth between different gestures. just this tremendous opportunity. Also, one of the things is if people are doing virtual environments, one of the first things people notice is it doesn't look very good, because if you're doing both a virtual environment and writing all that code, and you're trying to do all the artwork, and you're trying to do an animation system, and you're trying to do a facial system, it's just too much work for a computer science student to do, even in a couple of quarters. It's a couple of years worth of work. I started my system in 2001, and it really wasn't working, well, actually about 2000, and it wasn't really working well until mid-2003. So it's a good, solid 4 years worth of work. On top of that, you also have the work of a whole series of about several years worth of animators, which means you have a full gesture library, posture library, acting library that you can just use and drop on all of the characters. It's a little weird sometimes if you drop like the male voice on the female and they just do the full performance. Looks a little funny, but you can do it. That's about it. Any questions?
Is it possible, and if so, how hard is it to create a brand new character from scratch?
It takes us about a week to build a character from scratch. I think if you're doing it for the first time, it'll probably take you a little bit longer. We have a number of tutorials as to how to do it. All of our characters are fairly standardized. They don't have to be standardized. It's actually all programmatic. The characters, the models themselves actually have a little P-code language which they execute, which controls their face. But if you use all the defaults and you follow our rough guidelines, I think it'll probably take you, for the first time, maybe 3 weeks. Once you've done one of them, you should be able to get it down to about a week. We can really do it in about 3 days, but we got pretty good at it after a while.
When you're doing the phoneme alignment, are you doing that in a supervised recognition mode, or?
I'm embarrassed to say, I did the absolute simplest thing as an early test just to see what I could get away with. And my very first method, which was nothing more than I have a box filter that runs across for 0.1 seconds, my phoneme stream, that's all I do, and it does a decent job. If you want to get really close, you want to do a close-up. If you're doing Gollum, it won't cut it. If you're doing characters in an interactive environment, it's super cheap, it's super simple. It's also a great avenue of research. All of that system is fully exposed in the client. You can go through, you can change it with little difficulty. It's actually probably all of 50 lines of code. If you want to work on this, you want to put a real one in there, I think you'll see a dramatic improvement. Yeah. Anything else? What's next?
I was curious if you were going to show Paul Marino's little rap done with Face Poser.
I don't know if we brought that. It's wonderful, though.
Yeah, it's wonderful. There's somebody who just using their system from the outside, their Face Poser system.
We have a few demos from in the game. Who hasn't seen Half-Life 2 running? Okay, Mike, let's run Eli's lab, and then run Strider. These are demos we did, last year for a sales presentation at E3, which is the big computer game expo. So it's a little hypey, but bear with us. This is a demo showing off some of our character systems. You'll also see in the background the full radiosity
as an unexpressed axis.
lighting,
Effectively a dimensional slingshot.
other characters,
so you can
AI.
swing around the border world and come back in local space without having to pass through. Oh, here's Eli now.
All right, good.
Eli, look who I found in the airlock.
Gordon Freeman. Let me get a look at you, man. My God, you haven't changed one iota. How do you do it? Now, let's see. The last time I saw you, I sent you up for help after the Resonance Cascade. I never thought it would take you this long to get back to me. Welcome to the lab, anyway. It's not Black Mesa, but it served us well enough.
It's going to be a lot more like Black Mesa with Gordon here to help.
Right you are. MIT graduates are few and far between these days. We'll get you out of that hazard suit and back into your lab coat where you belong.
Well, let me just finish up some work and I'll see what I can dig up. Dr. Freeman, it's been a real honor. I'm looking forward to working together.
Feel free to look around.
Look around. And then the rest of the video has a player walking around, and the game actually detects them looking at pictures on the wall, looking at computers. The characters in the game have keys off of that, and then start commenting on what the player is looking at, and kind of fills out the world, makes it a little bit more interactive. Here's our action one. This shows squad behaviors, pathfinding, and then a lot of rendering effects, which you'll have access to. It's a little bit noisy, so just bear with us. It's for B3, so it has to be hypey.
Lead on, Freeman.
So basically what you saw in that video was squad behavior, pathfinding, dynamic lighting, physics interaction, IK. All the characters, the very tall striders, highly articulated, even minor mistakes in foot placement would be obvious. So they have a full IK system and a navigation system which allows them to walk in any direction. They're actually trying to find targets. They're communicating back and forth. Your other squad members, they're communicating as to what they should do. In this scene, they're actually told, you need to go stand in a dangerous place because you're supposed to die for the storyline. So they kind of do things they wouldn't normally do, but you have full control over that inside of the game. You also saw the character as he walked around. His legs were actually knocking over other physics objects. We have a full physics system, collisions. We don't have soft body deformations, but we have spring systems. And
it's also blending between 9 different animations. That's how it walks in any direction. It's blending between 2 and 3 separate animations at any time. That's how it's changing directions and walking backwards and turning at the same time.
And then there's a full IK system which finds the ground and also fixes foot skate and a few other things. Those come stock in all of our characters. And then we have a bunch of others, but they're pretty noisy. Doppler shifted sound. We have a full sound system. We have actually high dynamic range sound, which I don't think anybody uses. Basically, we record all of our audio at both a normalized around 60 to 80 dB, and then again for very loud things at 120 dB. We have those in separate channels. So so we actually get then, instead of peak to peak being 80 dB, we have this virtual sound which has both the high resolution at the low dB levels, but also it goes to full volumes. Explosions and gunshots have an impulse of around 120 dB, so we want to have the entire spectrum there. We also have other spatialization system, which allows us to fully spatialize high-speed moving objects around the player. Bullet whizzes are very important for our game, so it was kind of required. Also, the high dynamic range sound system allows us for like helicopter blades. Not only will it sound different as it goes farther away and gets close to you, but we also have occlusion. So as they go behind foliage or as they go behind other obstacles, the sound will muffle and get filtered depending on how far away they are and what the setting is for your humidity and your ambient temperature and your air pressure and so on and so forth. But these are just sorts of things that are hidden in the system that if you're interested in using, they're there, they come with it. Probably won't need it, but there's just this huge wealth of technology that has to be generated whenever you build an action game like this. You're using human scale protagonists against human scale antagonists in a highly realistic world. The world has to be very interactive. It has to be high speed. It has to have all of these characteristics that pretty much forces us to build this very high-powered general purpose engine. You don't need this kind of engine if you're doing a puzzle game. You don't need this if you're doing a racing game, but boy, once you have it, you can do a puzzle game and a racing game and all these other games inside of it. It's kind of the superset of all of those different games, which means when you get the SDK, you have this huge wealth of possibility in things you can do. That's pretty much it. That's my hype part. What do I do to get this?
Okay, I just have one more question. First of all, I want to say that what you guys are doing seems really great. And, you know, especially the idea of licensing to academics, because I know that I had talked to the Unreal folks, and their licensing is somewhat expensive. Just to be basic about it. I mean, so basically what I had done is I'd say, okay, we're going to use the regular Unreal Tournament. We can buy it for $10. All you guys go out and buy it, and, you know, we'll do mods with that, and that's just fine. The nice thing that they can do with that is that because it's such an old engine, you can run it on a laptop in a little window and debug while you're running. Pretty much, which of course you can't really do with this. And I was wondering if you could comment on the turnaround time between. Okay, you can.
Yeah. We spent a ton of time making sure that Half-Life 2 would run on older systems. So, like, basically all of the shaders have fallbacks. You know, basically everything has a fallback. I think the sound system runs at 22 hertz, kilohertz instead of 44. So there's, we did a lot of things. A lot of geometry cuts out. Models have levels of detail built into them, things like that. So it can run on older systems, or laptops, things like that, in a window.
You seem to be implying that compilation took a while and such.
Oh yeah, compilation can take a while.
And everything.
If you recompile everything, it can take quite a while. If you're just recompiling either just the client or just the server, it's a pretty easy process. But if you're recompiling all of the tools and everything else, if you're making a big systematic change, it'll be a little bit more, which we do all the time. It scales very well. I actually run the server in debug mode almost exclusively. We've actually done some things to find, like, okay, it's running the debug version of the constructors in this class. Okay, let's turn that off just so we can debug the rest of the application. So we've gone through and I think done a pretty good job of making the code very debuggable. We still have all the asserts in, we still have all the type checking in, we still have everything all throughout the code that ships with it. Which should save your students a lot of frustration when they make a small mistake.
Yeah, actually, I'm going to yell at my students when I go back because I have students doing Half-Life 2 mods that never told me a lot of this. So, thanks.
No problem. Let's see, what else do we got? Actually, yeah, you should talk about this.
This is just, we have an example of our water shader, which is probably our most complicated shader. Basically, here's what it looks like, and it's basically, we're adding all these things, these elements into it. So here's the base surface, just the base texture, unlit. Here's the normal map that we apply to it. Here's the lit normal map. Here's the texture with, basically the normal map applied. This is specularity we apply on top of that, so we've got a cube map that we're rendering on it. And then this is the water surface, which is basically rendering a reflection, of everything above it, and it's refracting everything below it. So that's like the final effect. You can do that again? Yeah, sure. So here's the scene where it's in. There's the texture, normal map, lit normal map, lit texture, specularity, and then the surface. And here's a. This is actually a picture of our level editor. Basically, this is where you're hooking up all the logic. You're designing the rough structures in the environment. A lot of the detail that gets put into an environment is built in XSI as what we call props. And the props, you can either mark them as physics props, so they interact, or they're just static pieces of the environment that just sit there and you can't do anything to them. So a lot of the detail gets thrown in. It's not actually built in here, but it's placed in here. So you compose the environment here. And then there's a screenshot of the environment that was in the editor there. I'll go back to it just to show it. You can kind of see it in the upper left. There's a shot of face poser, which you've already seen. What's that? Soundscape, probably.
Actually, I think that what that probably is, there's a thing called soundscapes, which define both the ambient background as well as overriding reverb characteristics and echo characteristics of the room, as well as sounds when a dramatic event happens. It's basically a whole soundscape of how the world should sound. But as you move through the environment, it also automatically adapts. So if you go into a small room, it detects that, it changes the echo characteristics of the mixer. As you go into large areas, it automatically detects the larger ambient area.
Do you get that for free, or is that?
That's all part of, we can talk for 2 hours about the sorts of things that are in the engine, but there's still a whole, all of it is easily accessible. There's just a lot of it. If you want to do all of it, it's going to be a huge project. But by us giving it to you, you have this huge system that you can just pick pieces of, replace them with what you're interested in, and you have all of the rest of the stuff for free. You don't need to build your own models if you don't want to, or maybe you're just building models. You just want to build characters. You don't care about AI. Say you're an art institution. Just build the models, drop them in. The AI will recognize the characters and just start playing on them. So it's all pretty straightforward. There is work. It's not trivial, but it's just, I would really recommend what you do for your class is you pick an area of focus and then just start replacing those subsystems. If you try to make an entire game, it's going to be 5 or 6 students for a couple of quarters, but if you just have individual student projects, I'd pick just a narrow focus.
Also, that's about it. Yeah. Questions? More questions?
How much code is there altogether?
That ships with the SDK? We actually haven't counted the lines, but I mean, 500,000, 750,000.
Yeah, easily.
Hard to say.
If you go through all of the subsystems and all of the tools and all of the, it's huge. To get started on an AI system, you probably need to know maybe 500 to 1,000 lines of code, one AI, and then some of the base class.
And can you say something about your use of C++? How sophisticated do you get? Is there a feature of the language you don't use?
I doubt it. I mean, especially the networking system gets really intricate. The solutions that we came up with for that, like I was saying before, the whole problem of you have a C++ class and you just want to access its members just like anything else. You want to say, your color is red, and then somehow the client, the server needs to know that changed and that the client is going to need to be sent that. So we have a really elaborate, that's like a study in itself. It's a really interesting system that we developed. Basically we construct this whole template class with a whole bunch of accessors, and we overload every operator. Then when it happens, we basically track the offset of the change, and then we look that up in this big thing to say which value is it. So yeah, we go pretty crazy with C++. But it's not like STL, unreadable nastiness. I don't know, it's pretty nice C++. Like vectors are probably the most common thing that you'll run into that use all the operators. We do vector math all over the place for the movement of things, for everything.
The complexity stages, we deliberately make some of the AI systems fairly simple, primarily because a lot of the programmers who write really good AI systems aren't necessarily the world's most sophisticated systems engineers. And so we want them focusing on making something fun. So we make those systems inherently a little simpler version of what C++ is. We may use multiple inheritance, but we don't necessarily use templates into that section.
Yeah, I should point out that what I was talking about, that system was designed so it can be easy to write the other code. That's something they should only ever have to look at if they want to torture themselves. With template code.
You can find most every bit of C++ in it, but
exceptions.
Except exceptions, which
and STL.
And STL, which we both removed.
Yeah, I was just curious. How big is the final executable? How much disk space does it take?
All the binaries are about 20 megs, and that includes all the versions of DirectX support and compiled shaders, all that stuff, the engine, the game code, all that stuff.
What's that to structure? Hello? It's actually structured as a bunch of different DLLs too. So, you know, you might have your own mod might not be 20 megs of code. You might have a small client DLL that only replaces a small one DLL.
Yeah, that'll be like 4 megs, 5 megs, what you'd be compiling it when you're changing the game.
So just to keep in the spirit of academic research, I have a question for Bay, since Bay was the one who kind of came up and did the researchy thing. Okay, so if I'm a modeler and I'm really, really good at making creatures look like something, and so my skills are sculptural, won't I balk at now I've got to come up with that look from the inside out rather than do what I've been doing for years?
That's a good question. I mean, when I sculpt, let's pretend that I'm that person. When I sculpt, I work in the sense of these are the rough proportions. This is the rough volume. This is the basic surface. These are the details I care about, and it's a 3-stage process anyway. So why not track that? Why not track that process and make it part of the authoring so that you can use it for animation and deformation?
Other questions?
Yeah, you guys rock. So,
thank you.
What would it take to get you guys to take the show on the road, to like come out to my place and show my students what you're up to?
Actually, Mike has a great mod talk, which is a little bit more exciting, a little less academic and more broad strokes as to all the features in the engine.
Yes, send me an email.
Absolutely.
It's up there, yeah, we'd be happy to.
Yeah.
So, perfect time.
Excellent. I think that's it.
Thank you. All right.
Thank you for coming.
Thank you guys very much. We have some gifts for you. I hope you won't find them in bad taste. They're
Halo shirts, aren't they? Yeah, we were
very much.
We love Halo. Don't get us wrong. We all played it. We all played it.